let's continue with our top interview questions. We have now done all of the array string questions, 2 pointers, and sliding window. So we're starting with matrix. Okay, valid Sudoku. Let's go. Start the timer. Determine a 9 times 9 Sudoku board if it's valid. Only the few cells need to be validated according to the following rules. Each row must contain 1 to 9 without repetition. Same for each column. Each of the 9 3x3 sub-boxes of the grid must contain the digits without repetition. Okay. Only the filled cells need to be validated. Okay. Ooh, oh my god, look at that. Okay, 5, 3. So this means it's not filled. Okay, so we want to determine if this board is valid. Okay, I see. Okay. So we are given this matrix and we need to check 3 conditions. For each row, each column, that seems to be very easy to check. And then we have these 3x3 sub boxes like this 3x3. And we also want to check if there's any repeating numbers. Okay, so this is matrix manipulation. I haven't done matrix problems for like, I don't know, half a year or 9 months. So let's get into it. We will get better at it the more we do. So this first one might take more time, but it will get better. All right, let's first check each row and column. Since this question is pretty straightforward, I'm not sure if there's any trick to make it smarter. So we have list of lists. That's our matrix, list of lists in Python 3. Okay. So the easiest will be the rows. That's just for each list. In this board, we want to check if there's any repeating character. So how do we check that? We could check it with a dictionary, and we could also check it with an array. Okay, let's just use dictionary. So row dictionary. So for each list, so for each row in board, that'll be more descriptive. So each of this is essentially a row. For each row in board, so this row is a list, and then for each cell, for each cell in row, if cell is not in the row dictionary, then we put it in there. If it's already in the dictionary, then we know that this is invalid. we can return false. We know right away that's already invalid. Now, after we have checked all the cells in this row and then all the rows in this board, we now want to check all the columns. So for columns, what do? We want to check the first index 0 of every list in this board. There might be better ways to combine this all together later, but for now let's just do this intuitive way. So column dictionary, so we have board. Maybe I do want to use index I and j instead of, okay, so we want to get the first index of each list in board. In range. So this would be the first row, and what we want is, okay, for j, in range, length of board 0. So that is first row length. That's the, oh wait, we just have a 9 times 9, so essentially that would just be 9. Okay, but this would at least work for all sizes of Sudoku boards. Okay, so we have this board. That's the length of the column. So for each column, we want to check the first index and then the second, so row and the column. Yeah, we might be able to combine this later. So for all columns, we want to look at the first column, and then we look at each row in the first column. If cell is not in the column dictionary, so we have the same logic here, else return false. Let's see if we are able to combine these two, row and board and cell in row. So that would be for each row in board. For each cell in board row, Okay, so for each row, so the difference there is just the order. Not quite sure if we can combine that. All right, let's think about that later. So now we have taken care of 1 and 2. Rule number 3, sub boxes. Okay, sub boxes. Oh, do we need to check? Okay, each of them is 1 to 9 or. Oh wait. Oh, so there's this. Okay. So that can be repeated. So if cell not in, if cell is a dot, then we can continue. Otherwise, okay, I want to do it like this instead. If cell is in a row dictionary, then we'll just return false. No, that's not correct. Okay, if it is a no, that's not good either. Okay, let's go back to if it's not, then we add it in the dictionary. If it is a dot, then we continue. Then otherwise return false. Okay. Alright, next part, which should be the trickiest part, these 3x3 sub boxes. How do we do that? 3x3 sub boxes. Let's name it box dictionary. So we need 3x3. Let's see. We still need the row and column. So row and column. Something similar. So row 0, 1, 2. So for row 0, 1, 2, and column 0, 1, 2. And then we want to go to 3, 4, 5, but still row 0, 1, 2. Let's do something like okay, now I have used the row and column everywhere, so let's try this. Row and column starting with 0, while row is smaller than 8, 9. we just need to do three round loop. Okay, row, column. So I is gonna always go from 0 to 1 to 2. Okay, so we are not at row 0. So what do we want to do here for J? In range 3 as well. What do we want to check? Need to check the sub box. To check row plus I, and we want column plus J. Okay, let's see if this will work. So if this cell is not in the box, then we put it in the box. If it's not filled, we continue, and otherwise we return false. So that's checking for a sub box. So we are at row 0, I is 0, J is 0. So then we have 0, 0, 0, 1, 0, 2, and then 1, 0, 1, 1, 1, 2, and 2, 0, 2, 1, 2, 2. So that should be one sub box. Now we have done one sub box. What do we do? So we are still checking the same row, but we wanna increment column by 3. So then we'll be checking still row from 0 to 2, and column would be 3 to 5. Yes, okay. Column. So after we have checked the second sub box, then we increment column once more, and then we have column 6, 7, 8. We're going to 6, 7, 8. Okay, 6, 7, 8. So 6, 7, 8, and then if we increment column again, it will go out of the while loop, so we can stop there. And then we wanna go to row 3. I think this should be the logic. Let's see if this works. Wrong answer. This is false. Let's see where it returned false. So print row, column, and cell. is it when it's checking for the rows? Output 155. 155. This is where it didn't work. Oh, I see. So we need to reset this for each row. Same thing for the column, and the same thing for the boxes. Okay, so this is one sub box. So this is one sub box. Okay. Promising. Oh, okay, almost there. Interesting. True. That will be giving us false. So it didn't fail here. Let's see if it failed here. What about this? Am I now showing the output? Oh, of course. Okay, my output is true, but expected is false. So, right, so I don't know what I was doing. So I returned true. Let's see, where should it give us false? I'm not seeing it yet. So all the rows are fine. All the columns are fine. And the sub boxes seem fine too. Oh wait, so this must be the sub box that's not working. 3, 4, something, 3. Box dictionary, range 3. So it wasn't working out here. So this is at row 8. Okay. Okay, what do I want to see here then to debug this little sub box? Returned, okay, so it returned false when it was at, okay. Let's see when it returned false. Okay, so it returned false at wait, okay, so I returned true 28 28 28. Oh, wait, okay, 28. Well, sorry, not my best day here. Really tired and sleepy. Okay, 0 0 0 1 1 1 2 2 2. So what are we doing here? Row at row 0, row 1, row 2. Okay, so that's right. So this, so it stopped after this one. Why would that happen? 2 8. Hmm. 2 8 3. Oh, I see. Okay, okay, I see. It needs to reset the column to go back to column 0 and then redo it. Right, okay. Ah, okay. All right. It's solved. It seems pretty fast, so that's good. So that part is checking the first rule, this is checking the second rule, and the last one is checking the last rule. I wonder if there's more Pythonic way to write this. Pretty sure there are. But this is the brute force intuitive solution. So one thing I could definitely refactor is, okay, let's do a little refactoring first. So this was helpful, the printing. Alright, so we see there's repetitive code. This is exact same logic. I'm sorry about the loud noise of my dishwasher and washing machine, everything's running. So let's have an additional function called, so we want to check the row, check the column, check the sub box, and we are using a dictionary to check those. Can we just name the function check? Check. Not a good name. Okay, check rule. Okay, a little better. Check rule. What do we need? We need a dictionary. Oh, actually, I don't know how to pass in the dictionary. Do I just say dictionary? Let's try that. We need to pass in a dictionary, and what else do we need to pass in? Row and column index. Oh no, we just need a cell. Okay, just need the cell. So what do we have here? If cell is not in this dictionary, I could just call it dict. If cell is not in this dictionary, then we put in the dictionary. If it's a dot, we can continue, otherwise we return false. If it doesn't return false, then we return true. Okay, so check rule, dictionary, and cell. So can we do this then? If check rule, row, dictionary, and cell is true, so if it's false, then we return false. Otherwise, we just continue. Okay, let's refactor that for the other two. If column, dictionary, cell, then we return false. And here if actually I know that we're supposed to use snake cases, which is underscore between all the words. I don't know why LeetCode always gives us these camel case function names. I thought the convention is to use snake cases. If check rule of box dictionary and cell gives us false, then we return false. Let's see if that works. Not sure if that is a valid syntax for Python. That's how we do it in other languages. Yeah, seems like that's not valid. Oh wait, continue. Not properly in loop. Oh, okay. So if we have this function separately, then we need to handle it differently. If cell is a dot, then we can just return true. Not defined. I've had this problem before. Still wasn't sure how to still very not used to this self in all the functions. It's still not defined. Actually, now I actually don't even know how to fix that. Self. This can't be it. I don't think this is it. It's really weird. Okay, so that works to use self dot check rule. So it works, but it's much slower. Let's just check one more time to be sure. Okay, I mean, I guess not that much difference. But in terms of runtime, so when we're doing it like this, when we have this dot, now it just returns true. Okay, it returns true, and then we go to the next round. I guess that's not really that much difference. Before we were just gonna continue, which means it goes to the next round anyways. Okay. not sure what else I could refactor. I could think about it for another 10 minutes, but it's already been so long. Do we have any follow-up or hint? Okay, no follow-up. Hash table. Okay, hash table, we're using the dictionary, so that seems to be good. Okay, all right. Let's do time and space complexity. So we are checking each row. We're checking all elements once. We check each cell, and we use the dictionary to do constant time lookup. So no additional time. Yeah, so each row and then each column, and then same thing here. We're just looking at each of these elements once. So essentially we looked at everything 3 times, but that is still the same time complexity in the same order. So this will be linear with respect to the amount of input in the matrix. So the amount of input in the matrix is simply 9 times 9, which is 81. And then we're looking at them, each of these 3 times at most, because we could cut short and return false anytime. So essentially it's a constant algorithm because the size is constant, but it will be linear to the size of the board, which is the size of the matrix, size of input. All right, so that's time. Now space, we are using 1 row dictionary. That's space of 9, 1 column dictionary, space of 9, and 1 box dictionary. So all constant as well. All right, let's have a quick look at the top solution and see if someone else has come up with brilliant ideas. What's happening here? What is this? 4 in row 7, 4 in column 7, top right block. Oh, okay. Well, look at that. Instead of these 3 separate parts, we now just have this one simple, elegant solution. Okay, so for ij goes from 0 to 8. Board, if it's not dot, then okay, we're gonna code it in this format. So scene is a dictionary. If we haven't seen it in B plus I, B plus I, B plus I is row, so that's okay, that's that. J column plus B, okay. And we haven't seen it in okay, so that's the index for that block, the sub box. very smart. Yes, okay, that will be in that format. So anytime we have already seen it, it will be there. Return false. Okay, so when did we actually put it in the dictionary though? Scene add. Okay, so I assume this is adding it to the scene dictionary if it is not in there, and if it's already in there, it will return false. Okay, I see. Wow, this is very brilliant indeed. Okay, wait. So we have this. So what is the, okay, read the problem again, particularly the note section. Only the failed cells need to be validated according to the measures. Okay. Not quite sure what is wrong with that solution. Okay, all right. Let's see. Okay. Okay. Okay, so very smart indeed. Oh, let's look at the Python solution. I see. So it put all the input inside the set to check if there are any invalid, which is duplicate. So if there are no repetitive numbers, it will be the same length. Okay, all right. Interesting, brilliant solution, top solution, pretty brilliant. All right, very outside of the box. Okay, so that's it for this problem. I think we are gonna get used to matrix and we're gonna get better at it. So I will see you in the next problem.